Welcome to the Deep Dive. You've given us your sources, your curiosity, and we've dug in to bring you the most crucial bits, tailored just for you.
And today we're tackling a really big one, the whole buzz around potential life signs on exoplanet K2-18b.
Yeah, this one definitely made waves. It's the kind of news that gets everyone excited, right? Possibility of life out there.
Absolutely. It touches on those, fundamental questions.
So the story kicked off with reports about detecting certain gases, specifically dimethyl sulfide DMS.
Right. And the key thing, the reason it caused such a stir is that here on Earth, DMS is mostly made by life. Think marine algae, that sort of thing.
Exactly. So boom, headlines talking about the strongest evidence yet for alien life. That was really the initial big takeaway, wasn't it? Finding this gas linked to life on Earth way out there on K2-18b.
It was. I mean, you find a molecule like that, especially one so tied to biology here, and your mind immediately goes there. It's natural.
But, science isn't really about jumping to conclusions. And that's what we're diving into today. Not just the initial hype, but the scrutiny, the follow-up, the whole scientific conversation around it.
Yeah, think of this as your kind of shortcut through all the claims and counterclaims. We're trying to piece together what the actual picture looks like now.
And we've got a great mix of sources. You pointed to Reddit discussions from the SurSpace folks, a proper scientific paper trying to define life from PubMed Central, news reports.
Space.com, AS Nova, KSU Public Radio, Nat Geo, Science Alert.
Yeah.
Yeah, good cross-section. Shows how the story unfolded in different places.
Okay, let's rewind to that first way. The University of the Cambridge team, they used the James Webb Space Telescope, the JWST.
The big gun.
And they reported finding DMS on K2-18b. Why was that finding specifically such a big deal?
Well, like we said, on Earth, DMS is, pretty much a biological product. It's linked to metabolic processes, especially in the oceans.
So finding it elsewhere immediately flags potential biology.
Exactly. That's the implication. And the researchers themselves, they were quoted saying things like, it was a revolutionary moment, the strongest hints yet. Pretty strong words.
Very strong. Do you think maybe those bold claims right at the start perhaps overshadowed the usual scientific caution, made people jump ahead?
It's possible. It generates excitement, which is good, but also maybe sets expectations very high. And the planet itself, K2-18b, adds to the story.
Right. Tell us about the planet. It's not like Earth, is it?
No, it's a super Earth.
Yeah.
Much bigger, nearly 9 times the mass, about 2.5 times the size. And crucially, it orbits in its star's habitable zone.
The Goldilocks zone, where liquid water could exist.
Potentially, yeah, that's the idea. So you had this possible biosignature gas, DMS, and a planet in the right place for liquid water.
Yeah.
That combination.
It's pretty compelling.
Very. And it tied into discussions about these theoretical Haitian worlds, too. Planets with, global oceans under hydrogen-rich atmospheres. A very alien environment, but maybe habitable.
Okay, but science being science. That initial excitement wasn't the end of the story.
Yeah.
Far from it, right? This is where the scrutiny kicks in.
Oh, absolutely. This is fundamental. One team finds something interesting, especially something this big, and other teams have to try and verify it. They look at the same data, run their own analysis.
Like Eddie Schwieterman said, having multiple groups checking the data is exactly what you want to happen.
Precisely. It's how the system is supposed to work. And, well, that's what started happening. Independent researchers started looking really closely at that DMS detection.
And they weren't all convinced.
No. People like Joshua Kersanson-Totten, Laura Kreidberg, they raised doubts. They questioned how strong the evidence for DMS actually was in the JWST data.
Okay.
And others, like Michaela Misalova, stressed that, extraordinary claims need extraordinary evidence. You need independent confirmation, statistical significance, and critically, you have to rule out non-biological ways the gas could be there.
Ah, the abiotic explanation. So the counter-narrative started building.
Mm-hmm.
Maybe the DMS signal wasn't that strong. And even if it was there, maybe it wasn't life.
Exactly. And then came other discoveries like finding DMS on a comet, a completely lifeless object. That really complicates the picture.
Right, the whole false positive problem.
Yeah.
Our sources mentioned the phosphine on Venus story as a kind of cautionary tale, didn't they?
They did. That was another case where a potential biosignature got a lot of attention, but then faced intense scrutiny, and the evidence just didn't seem to hold up as definitively biological under reanalysis.
So does that whole Venus episode make the bar even higher now for claiming a biosignature detection? More skepticism built in.
I think it has to, yeah. It shows how careful we need to be, how easy it is to potentially misinterpret something, especially when dealing with complex atmospheric chemistry light years away.
So, okay, we have doubts about the DMS signal itself and the possibility it could be made without life. But what about the planet, K2-18b? Is it even the kind of place life could exist?
Well, that's another major point of debate now. Even if you ignore the DMS issue for a second, is K2-18b actually habitable?
Wasn't it supposed to be in the habitable zone?
That was the initial assessment. But some more recent modeling suggests it might actually be too close to its star, too hot for liquid water on the surface. It might be outside the habitable zone, after all.
Too hot. How hot are we talking?
Well, some researchers, like Raymond Peer-Humbert, have suggested it could be hellishly hot, maybe even having oceans of lava instead of water.
Okay, lava oceans. Definitely not great for life as we know it.
Not exactly welcoming, no. So the whole Halcyon Ocean world idea started to look a bit shakier.
And didn't that comet discovery, finding DMS on a cold, dead comet, also feed into this?
Absolutely. That was a big finding in 2024. If DMS can exist on a comet, it means there must be ways to form it without biology. Abiotic pathways.
So maybe K2-18b is making DMS through some weird non-living chemistry we don't fully understand yet.
That's definitely on the table now. As Michaela Musilova pointed out, it opens up the possibility of unknown chemical processes. And adding to that, there were reports about a reanalysis of a Cambridge team's earlier data from 2023 that apparently found no evidence of DMS or even carbon dioxide, which would also challenge that Hyson world model. Suggestions came up that maybe K2-18b is more like a gassy planet with no real surface, or maybe it has a magma ocean.
Wow. So the picture's getting really blurry now, from strongest evidence yet to maybe a hellishly hot gas planet with no life signs at all.
It's a pretty dramatic shift, isn't it?
It really is. And it brings up a more basic question. When we talk about searching for life, what are we actually looking for? What even is life?
The million-dollar question in astrobiology. Our PubMed central source touches on this. Defining life is surprisingly tricky. There's ongoing debate.
Is there a working definition people use?
NASA uses one. A self-sustaining chemical system capable of Darwinian evolution. That's kind of the benchmark.
Self-sustaining, capable of evolution.
Yeah.
Okay.
So it highlights why finding just one molecule, like DMS, isn't enough proof on its own. You'd ideally want evidence of a more complex system, something that replicates, evolves.
That Darwinian evolution part implies imperfect copies, heritable traits, selection. That's a high bar to clear with remote sensing, surely.
Extremely high. And it shows the difficulty of finding a truly universal biosignature, a sign that only life can produce anywhere. DMS, as we've seen, might not be it. You always have to rigorously check for those non-biological mimics.
Someone on that Reddit thread, First Space, brought up an interesting point. Maybe looking for signs of intelligent life like industrial pollution would be more definitive?
Yeah, that came up. It's an understandable thought. Something artificial seems less ambiguous.
But it feels a bit human-centric, maybe.
It is quite anthropocentric. As others pointed out, Earth had intelligent life, arguably for millions of years, think dinosaurs, before humans started polluting in ways detectable from light years away. Simple microbial life might be far more common, but much harder to spot.
Dinosaurs didn't exactly leave atmospheric technosignatures, did they?
Not that we know of. So yeah, detecting simpler life is the bigger challenge, especially across these huge distances.
Which really highlights the tech limitations, doesn't it? We're talking 120 light years to K2-18b. That's just...
vast.
It's mind-bogglingly far.
Makes our most powerful telescope seem, well, still limited. Direct confirmation, like sending a probe. That seems like science fiction for now.
Oh, absolutely. The Reddit threads discuss this. Sending a probe is a project for centuries, maybe millennia, with current tech. Just the communication lag is over 200 years for a round-trip message.
Puts things in perspective. So are we just stuck squinting at blurry data for the foreseeable future?
Well, there's definitely optimism, too. JWST itself is still new, relatively speaking. The full data set from these recent observations, it's going to become public. More scientists will get to analyze it.
More eyes on the data. Exactly. And technology keeps improving. That UCL Discovery article talked about how JWST and also the European Space Agency's upcoming aerial mission can help characterize K2-18b's atmosphere better.
How do they do that?
By using really sophisticated computer models, spectral retrieval, to analyze the light filtering through the planet's atmosphere. They try to figure out which gases are present, how much, maybe even if there are clouds. The models can help distinguish between, say, a water world scenario versus a gassy planet.
Interesting. So comparing the actual light signature to these different models.
Pretty much. And apparently JWST is particularly well suited for this kind of planet, needing fewer observations than Ariel might to get meaningful results.
And beyond JWST and Ariel, the Source-Based folks mentioned future projects.
Yeah, NASA's talking about a potential habitable worlds observatory down the line, and there were even discussions about feasible concepts for high-res imaging eventually. Imagine actually seeing continents or maybe even city lights on an exoplanet's night side one day.
Wow. Okay, that's still a ways off, but it's incredible to think about.
It is. The capability is always advancing. So while definitive answers are hard, we are getting better tools all the time.
Looking at this whole K2-18b saga, from the initial headlines to the current debate, it really feels like a textbook example of the scientific process, doesn't it? Messy, maybe,
Yeah.
but working.
Absolutely. It's science in action, warts and all. You have a potentially exciting finding. It gets announced, then the community dives in, scrutinizes, offers alternative explanations, gathers more data. It's iterative.
And that skepticism isn't negativity, it's essential, especially for claims as big as finding alien life. Extraordinary claims require extraordinary evidence.
Right. That's the mantra. And it's crucial here. This whole process reminds us that there's still so much uncertainty in studying exoplanets. Answering that ultimate question, are we alone? It's going to be a long, challenging road.
Okay, so let's quickly recap this deep dive for everyone. We started with that burst of excitement. DMS detected on K2-18b, a gas linked to life on Earth.
Right. But then came the crucial scientific pushback. Questions about the data, about the planet's actual habitability, maybe too hot, maybe no surface.
And the discovery that DMS can exist without life, like on that comet, further muddying the waters.
Plus the ongoing quest for better technology, like JWST and future observatories, which are key to getting clearer answers down the line.
So that initial strongest evidence yet claim, it's definitely being heavily reevaluated right now.
It is, but the process itself, this cycle of discovery, scrutiny, and refinement, that's how we learn. That's how science moves forward, even if it means dialing back initial excitement sometimes.
It's just one piece of this enormous puzzle we're trying to solve about the universe.
A fascinating piece, though, and a great illustration of the journey.
So here's something for you to think about. When we hear potentially revolutionary news like this, how do we balance that natural human excitement, that hope, with the need for scientific rigor and patience, especially when the stakes are as high as finding life beyond Earth? It's a tricky line to walk, isn't it?
It really is. Keep asking questions, stay curious, and definitely keep an eye on future findings from K2-18b and other worlds. The search continues.
Thanks for joining us for this deep dive.